Hello everybody, this is the notes for section 10.1. All right, we're going to go back to doing more of a normal class that we've done for most of the year. Chapter 10 is dealing with, like it says, properties of circles. You draw segments in circles, you draw some angles in circles, and they all have relationships with the circle and the segments. So, first section here, doing some defining and a couple of little properties. So let's get going here. All right, first couple things. We know what a circle is. We've talked about it lots of times. All the points on a circle are equidistant from that center point, and that distance, that is called your radius. That's this red segment here. Goes from the center to the circle. A new term is called a chord. A chord is a segment whose endpoints are on the circle. So that's this green segment here. Endpoints are on the circle. That is a chord. Now, you know what a diameter is, but I don't know if you've heard this, is that the diameter is a chord. Okay? It's a segment whose endpoints are on the circle. It's just that the diameter is a chord that goes through the center. Now, these first couple terms were segments. If we start talking about lines that go on forever, a secant is a line that intersects a circle at 2 points. But the key thing is it's a line, just crossing the circle at 2 separate points. A tangent is a line on the same plane as a circle. That's kind of key. It's a line that intersects the circle only at 1 point. So basically it just touches the circle, and that's this line down here. It just touches at point B and then keeps on going. So there's only one intersection point. Now, the definition of a tangent is a line, but you can have segments that are tangent to a circle. You could have rays that are tangent to a circle. It's just the proper definition is we're dealing with a line. That point where the tangent line touches a circle, that is called your point of tangency. All right. So just a couple of terms there. I would like you to answer this top question. How many times can 2 circles intersect each other? I want you to draw a couple different things, leave some space on your paper, but draw it and see how many times 2 circles intersect each other. And then we'll talk about it in class. Okay, so hit pause, give that a little bit of thought, and then come back. A line, ray, or segment that is tangent to 2 coplanar circles is called a common tangent. So looking at this picture on the bottom left, we got 2 circles. It really doesn't matter if they're different size or not. But a common tangent is a tangent line that's tangent to both circles. So this is going to be a rough sketch. This is a common tangent. There's a point of tangency on one circle and on the other circle. That's a common tangent. So how many common tangents do these 2 circles have? Well, pretend that was really close. Okay, there's another common tangent. This one has 4. If you start going on the inside, point of tangency, and right there, that's a common tangent. Do the same thing here. Point of tangency there, point of tangency there. There are 4 common tangents for that. All right, on the right side, I would like you to do this, and again, we'll talk about it in class. Draw 2 circles that have 3 common tangents. So give that some thought and try it out. All right. So the first property that we're going to be dealing with for this chapter is on the top here. When you have a tangent line and you draw in a radius to that point of tangency, it's always going to be perpendicular. The radius and the tangent line are perpendicular at the point of tangency, always. So when you have a tangent line and you connect, you're looking at this bottom picture here, we got this, what could be a tangent, this line BC. We have a radius, that's AB, and then we got a distance from A to C, that's 67. The question is that a tangent? Is BC a tangent? So if it was a tangent, if BC is tangent, then this should be a right angle. So how do you check to see if it's a right angle? That's Pythagorean Theorem. Legs squared plus legs squared should equal hypotenuse squared. So I'm putting a question mark there because that's what we're trying to figure out. The question is that a right angle? So you do 25 squared. You add that to 60 squared. You get 4,225. You do 67 squared. 7, carry the 1, 4,489. Those are not equal. So this is not a right angle, which means BC is not a tangent. Okay. Another thing I would like you to try to do that we'll talk about in class. Look at this picture. What we have is two tangents. They're both starting at point A, both going to the same circle. What must be true about these two tangents? So I want you coming up with an idea of what you think is true. And I want to know why. So to help with the why and to help get the property, I would draw in one radius, draw in another radius, and then connect the center to point A. That gives you a whole bunch of information. Okay, I want you to come up with what you think is true about these two tangent lines, AB and AC, and I want you to come up with some justifications of why you think it's true. All right, hit pause, work on that. We'll talk about it in class. Once we talk about it in class, we'll do this problem and this problem. So that is it for the notes. Hope you have a good night, and I'll see you in class tomorrow.